Looking at lesson 4 for Unit 1 here. We're now in a different chapter within your book. Unit 1 is kind of a mix of like 3 or 4 different chapters for just some basic ideas. These are all Algebra 1 concepts that we're looking at, and so we group these all together within Unit 1 here. But what we're going to be looking at for the next couple lessons are solving a system of equations, which I know you guys have done in Algebra 1, you did it in Geometry, you did it in Algebra 2, all that good stuff. So anyway, for today's lesson, for lesson 4, we're going to be looking at 2 methods for how to solve a system of equations. One is by graphing, and the other one is by use of your calculator. So let me start with the basic graphing method first. So if I were given these 2 equations and I were asked to solve this system of equations, if we're going to do it by graphing, then we have to put it into graphing form, which is slope-intercept form, or y equals mx plus b form. So if you take your first equation right here and you add 2x over to the other side, it would look like this, and now it is in slope-intercept form. Same thing with the bottom equation. If I subtract over the x and then divide everything by 3, I get this look here. And again, I have the y equals mx plus b form. And so we would graph these. And so you have to do these on graph paper when you do these by hand, but the first equation would start at -3. That's our y-intercept. So here we are starting at -3. You can see the slope is 2, or we would see that as 2 over 1. So rise over run, I'm going to rise 2 and run 1. So if I were to go up 2 over 1, I can make my next point. And that's enough to make your graph. But I would always encourage you to make more than 1 point just for accuracy's sake. So I'm going to continue to go up 2 over 1 and make another point, up 2 over 1 and make another point, and now I'm going to have a really accurate, nice line on my graph paper. Same thing with the other equation. We're going to start at +4. That's our y-intercept right here at +4. And then this one has a slope of -1 over 3, so we're going to go down 1 over 3, down 1 over 3. And so there's a couple points, draw the line. To solve a system of equations, as you remember, by graphing is just to find out where they intersect. So this is an x, y ordered pair combo of numbers that satisfies both equations. So that's what we're looking for. And if this is done right on the grid, then we can see this is cleanly landed on 3, 3. So that would be our answer. Our x is 3 and our y is 3, and that's the solution to that system. Of course, there are times where it doesn't land on integers like this one did, and you're in between the lines, and so now you need another way of coming up with your answers because you can't tell just by looking at the graph. And so this is where the calculator really comes in handy. So I'm going to teach you how to solve these on your graphing calculator. By the way, when you see the letters GDC, this is like what they always say on like IB tests and things like that, is use your GDC. That's your graphing display calculator. So we're going to use our GDC, or the graphing display calculator, to solve this system of equations. So I'm going to kind of go back and forth here between the calculator and the notes. And so I'm going to try to get this all on there at the same time if I can. But we're going to start by graphing this equation. So if you go to your calculator, so right here where it says y equals, if you go to, after you turn it on, if you go to y equals, and you pull up your graphing screen, and we're just going to type in exactly what I see right here, which is 2x minus 3. So 2, and then this button that you see right here with the x on it is the button that you use for x. So I'm going to hit that for x, minus 3. So that's what that would look like. Make sure, let me go full screen on this for a minute so I can show you. So make sure that you know the difference between when to use your minus sign versus when to use your negative sign. So if you're ever putting something like -1/3, like we're going to do here on the second equation, I got to use this as my negative button. But if it's 2x minus 3, like the one we're doing now, you got to put this minus sign. If you use the wrong one at the wrong times, your calculator won't work, and it's going to say error or something like that. So make sure you know which one of those to use. Anyway, I got 2x minus 3. I'm going to hit enter. So I can now plug in my second equation. And the second equation you can see is -1/3 x plus 4. So that's what I'm putting in. So I'm going to do -1 divided by 3 x plus 4. So there's my second equation. And right here, the graphing button, just hit graph. It's going to graph them both. So there was the first one. Here comes the second one. So I can see that's their point of intersection. I just have to identify what those coordinates are. So right here under Calc is where you find all the cool features to use from your graphing screen. So it's in blue, so I got to hit second, Calc. And option 5 is where they intersect. So I'm going to hit enter on that one. The calculator is going to ask me a couple of questions, but I'm just going to keep hitting enter. So they're going to say, you can see the cursor right there. It says, is this your first curve? So we just hit enter. Is that your second curve? We just hit enter. It's going to say guess. We always just hit enter. And there you go. Our answers are at 3, 3. And so that's our solution. Like I said, some of these will not fall on integers, and they're a little harder to identify what those numbers are. So let me just toy with one for a minute, but I'm going to go back into y equals. What if this were minus 4 instead of minus 3? And so watch what happens now. When I go to graph them, so there's the first one, here comes the second one. I can see where those graphs intersect, but if I go to second, Calc, and choose intersect, so enter, 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 look at those numbers. Obviously I do not get nice clean integers. Well, what if my directions on my test ask me for exact answers? I can't just write those down. Those numbers continue on and on forever. These are not exact answers. So how do I get an exact fraction answer out of this? Well, notice this is x and this is y. So watch what I do here. I'm going to go to quit. So I'm just going to quit back to my main screen. So second, quit. To pull up my answer for x, that is this x that you see in green on the calculator. So I'm going to hit alpha x. And so right there it pulls up the x. And if I just hit enter, here is the same value that I was just looking at for x on the last screen under the graph. Well, if I want my calculator to give me that as an exact fraction, well, if you go under math, that first option that says fraction, just hit enter, enter, and there we go. Now I have the answer as an exact fraction, and I don't have to round it. I don't have to use 3 sig figs. I have the exact fraction answer if I want to go this way. Of course, if it said 3 sig figs, then I would have just done 3.43. But again, if the direction says an exact answer, this is what I have to do to get the exact answer. Same thing for the y value. If I want to pull up the y answer, right, let me find it for you, right there, that green y. So if I hit alpha y, I can pull up the value for y. I'm going to hit enter. So there it is as a decimal. But what if I want that as a fraction? So I hit math, hit enter for fraction, enter again, and now I have that one as an exact fraction as well. So that's a way of getting exact answers by using your calculator and by using the graphing feature of your calculator. So again, we can do 3 sig figs. It's just a matter of following directions. So if the directions say they want an exact answer, this is the steps that you would have to take in order to get that exact fraction. All right, let me go back to this guy for a minute. I mentioned some other things on here, like with it using a matrix and whatnot. Notice I crossed those out. I no longer teach that because it was just more trouble than it was worth. We have a way of doing this in the calculator. That's what I just did for you. So we have a way of doing this by hand. We also just showed you the way of doing it with your calculator by using the intersect feature of the calculator. And so that's all we're working on for today's system of equations, are those two methods. I want to show you two quick special cases. There is a no solution case as well as the infinitely many solution case. If you were to graph the no solution case on your calculator, what you would find is that you have parallel lines. These graphs don't ever intersect, therefore they have no solution because there's no point of intersection. So anytime you have parallel lines, meaning they have the same slope, and that's what you're seeing right here. If they have the same slope, but they start in two different places because they have a different y-intercept, you got parallel lines, they would never intersect, and so that's our no solution case. So I'll just throw one onto the calculator really quick for you to show you. But here we go. Let's say 2x minus 4. What if I had 2x, clear that out. So 2x, so I'm going to give it the same slope, but a different starting point. So they have the same slope, but different intercepts. So here comes the first one, here comes the second one. So notice we got parallel lines. They had two different y-intercepts, but they had the same slope. They're parallel lines, so they have no solution. So that's a no solution case. And your other case is the infinitely many solution case. This is the case where they have the same slope and the same y-intercept, meaning they're the same line. It's like putting one line right on top of the other line. They would intersect everywhere. They intersect in infinitely many places. So there's an infinite many solutions to this case. So notice right here, if I just took that top equation and multiplied it by 2, this is what I get. It's the same line, right? I got the exact same values for both equations. I don't need to graph that to figure out that it's the same equation. So I should be able to label that as an infinitely many solution case without having to graph it. So those are your two special cases. So just two cases you got to be on the lookout for. But otherwise, everything else will play out within the ways that I showed you up here.